So our last example is a more concrete example of a differential equation. We have a ball that's thrown upward with an initial velocity of 64 feet per second from an initial height of 80 feet. So they give us some information, right? They want us to find the position function using integration. So I know that you have the position function memorized and could build it just from this. But what we want to see here is where that position function comes just based on integration and the acceleration of gravity. All right. And then we want to find when the ball hits the ground. So we know the acceleration of gravity is negative 32 feet per second squared. We know two initial conditions. The initial position, that's the initial position, is 80 feet. The initial velocity is 64 feet per second. So if we want to get position, we're going to have to take the acceleration and integrate it once to get the velocity function, and integrate it again to get the position function. Right? So this is, we know the velocity is really the first derivative of the position, and acceleration is really the second derivative of the position. So it's just like this last problem that we did when we had f double prime and we wanted to find f. Here we have a, the acceleration, we want to find the position function. So when we go to do that, to find the first derivative of the position, that's the velocity. So we're going to find the indefinite integral of the acceleration. We're going to find the antiderivative of negative 32. That's negative 32t plus some constant. So I know that v of t equals negative 32t plus c. I'm going to plug in that initial velocity that I have. I was told v of 0 equals 64. And I plug in 0 to v of t, so I find c is 64. Right? That means that my velocity function is negative 32t plus 64. Now I want the position, so I'm going to take the antiderivative of velocity, the antiderivative of negative 32t plus 64. So I leave the negative 32 coefficient. I add 1 to the exponent, divide by the new exponent. It gives me t squared over 2. 64, antiderivative of that is 64t, and I have another plus c. And again, I know that the initial position was 80, so I plug in t equals 0, set that equal to 80, and solve for c. So I get c equals 80, and therefore the answer, the position function, using integration, looks like this. The position is negative 16t squared plus 164t plus 80. Now the next question is, when does the ball hit the ground? When that happens, my height will be 0. So the position will be 0 when my ball hits the ground. So I'm going to factor out that negative 16, divide both sides by negative 16, factor out the t squared minus 4t minus 5. I get t equals 5 and t equals negative 1. For this application, the negative time doesn't make any sense, so the ball hits the ground after 5 seconds.